Okay, good morning. I'm going to show you an example of how to find critical points and possible points of inflection for a given function. And our first example is function g. It is a polynomial. I've written it in factored form. -1/8 times the quantity x plus 2 squared times the quantity x minus 4 squared. Okay, and we recall that the critical points are the zeros of the first derivative and where the first derivative might be undefined. The possible points of inflection are the zeros of the second derivative and the points at which the second derivative might be undefined. All right, let's start by finding the first derivative of g. And we see we have a product, and we're going to have to use the product rule. So I'm going to take the derivative of that first factor using the power rule, bring down the 2, leave the base, subtract 1 from the exponent, and leave the other factor alone. And to that I'm going to add, now I leave the first factor alone, and I'm going to multiply by the derivative of the second factor. Oops, that should be a minus. Okay, now maybe to clean up just a little bit. Alright, so I have -1/4 times x plus 2 times x minus 4, the quantity squared. And cleaning up here on the second term, 2 times -8, so that's another -1/4 times x plus 2, the quantity squared, times x minus 4. Okay. And we see that both terms have a coefficient. Actually, that coefficient's in common. They each have a factor of x plus 2. And they also have a factor of x minus 4. And so for finding the critical points of g, I'll want g prime to be factored. And instead of doing any kind of expansion, I'm going to factor out the greatest common factor. I'm going to factor out a -1/4, 1 factor of x plus 2, 1 factor of x minus 2. And since this original g prime was a difference with 2 terms, I expect 2 terms to be here inside these set of parentheses. Well, I've factored out the -1/4. So looking here at the first time, I've also factored out the x plus 2, 1 factor of x minus 4, leaving 1 factor of x minus 4 in the parentheses. Similarly, I've already factored out the -1/4. I've factored out 1 factor of x plus 2, so that leaves 1 factor of x plus 2 within the parentheses, and the other factor has been factored out. So the factored form of g prime, -1/4 times x plus 2 times x minus 4 times 2x minus 2. And it would be up to the person doing the work, but you could also factor out another factor of 2, but I'm going to stop there. Now g prime is also a polynomial, so g prime is defined everywhere on the entire domain of g. And now I set g prime of x equal to 0 and solve to find any critical points. Well, that's going to be straightforward now that I have the factored form. So I set that factored form of g prime equal to 0. And using the zero product property, if this product is 0, then one of those 4 factors is 0. And clearly the coefficient can't be 0 because that's a constant. But the other linear factors we can set equal to 0. And we have found our zeros of the first derivative. -2, 4, and it looks like also 1. Critical points of g. Okay. So we may stop the video here, and when we return, part 2, we can find where the second derivative equals 0, and that'll be possible points of inflection.